Good day, everybody. How are you all? Today we are going to talk about a small sample hypothesis test. Okay, so I will share my computer screen with you. Statistics students think that the mean score on a statistics test is 65. The teacher of the statistics class believes that the mean score is higher than 65. He selects a simple random sample of students and records their scores as follows. So the scores are given. Test the teacher's hypothesis at a significance level of 0.05. Assume the sample test scores come from a normal population. So solution. Sample test scores come from a normal population. But the population standard deviation is not known. Deviation is not known. In this case, we will use t-test. Okay. So we have to calculate the test statistic to the hypothesized. No, we have to calculate the test statistic. Just a minute, I have to erase this. Which compares, the test statistic compares the sample mean to the hypothesized population mean. Hypothesized population mean. In terms of the standard deviation of the sampling distribution. Terms of the standard deviation of the sampling distribution. Okay. So let's state the null and the alternate hypothesis. I will write H sub A for the alternate, makes it easy. The teacher thinks that the mean score is higher than 65, mu greater than 65. Notice here the two slanted lines making greater than points to the right. It's a right tail test. What does it mean? means rejection of the null hypothesis falls in the right tail. Okay, so H sub 0 is my null and H sub A is my alternate. So if mu greater than 65 is the alternate, that's what the teacher wants to test, then the null hypothesis contains the opposite sign as well as the equal to sign. Null hypothesis will always contain the equal to sign. Okay, so that's the null, that's the alternate. So test statistic is T, which compares the sample mean to the hypothesized population mean divided by standard deviation of the sampling distribution, which is given by this whole thing. Okay, what is mu 0? Mu 0 is the hypothesized population mean x bar is the sample mean and S is your sample standard deviation. N is your sample size. Sample size. Okay, so I'll reduce this a little bit more. And then maybe this a little bit up. Okay, so to calculate S and X bar, enter data in L1 of TI-84. L1 means list 1 in TI-84 calculated. So we do stat. Now first we clear the memory. So let me erase this. And let's go with this and erase this. Oops. So first we'll press the second button in our calculator. Then the plus button, which is on top of the enter button on the bottom right corner. Then we will select number 4. We will get clear all list. And then we hit enter. And we get done in the calculator. This step clears the memory of the calculator. Clears the memory of the calculator. So second button, plus on top of enter, number 4, clear all list, then hit enter, done. Now what do we do? Press the stat button and then number 1. Enter data in L1. In L1. So stat button, number 1, enter data in L1. What data we are going to? We are going to enter the sample data, which is 65, then 65, then 66, then 63, then 63, then 64, then 67, and then 68, then 72, then 71, and then 70. Okay, so we have entered data in L1. Okay, now let's create some space. Okay. Okay. Now we will press the Stat button. So Stat button again after entering the data. This is Stat. And then highlight Calc on the top row. And then select number 1, which is 1 where stands for variable stats. Okay. Then they ask for list, which is L1, which is already there. Next line, frequency list should be empty. If there is something after the colon, press the clear button and then calculate. Bring the cursor or the black rectangle or calculate and hit enter. Okay. So X bar is 66.72 and SX, that's the sample standard deviation, is 3.165. Okay, we need these two information and we know our sample size N, sample size is equal to 11. Okay, now remember null hypothesis is mu less equal to 65. This is 65 is the hypothesized population mean. Hypothesized means the educated guess of the teacher. Hypothesized population mean. Population mean. Okay. So let's calculate the test statistic T. Test statistic T. What do you say? What is test statistic? It means the characteristic of the sample. So is equal to X bar. X bar is 66.72 minus mu sub 0, which is the hypothesized population mean, which is 65, divided by parenthesis Sx is 3.165 divided by second button and then x square button, which is in the first column halfway down, gives me the square root. Inside the square root, sample size 11. Close the parenthesis and hit enter. So let's do it exactly the way I have done. T is equal to left parenthesis 66.72 minus 65 divided by left parenthesis 3.165 divided by second x square gives me the square root. Inside the square root, sample size of 11, right parenthesis and hit enter. The test statistic T is equal to 1.802. Okay, this is your test statistic. Okay, the question is, what is the probability? So I will write everything down. Let me create some space by moving this up. Okay. Okay, let me go back. So this is a picture of the T distribution. This is a T distribution. What does it mean? It means T values on the horizontal axis. T on the horizontal axis and probability on the vertical axis. Okay. So at the center where the peak is the highest, maybe I should erase this and redraw it because it got a little bit slanted. I don't want that. So let's go back here and let's try to connect this point with this point over here. That's more like it. There's the peak. That's the value on the horizontal axis where the peak is the highest, relative frequency is highest. This is t is equal to 0 at the center. Okay, t is equal to 0. Now our test statistic, so on the right of 0, we have positive values on the horizontal axis. On the left of 0, we have negative values on the horizontal axis. The t value that we have calculated, the test statistic, is 1.802, somewhere over here. And this is your 1 point. So let me erase this and write it clearly. So this t value, the test statistic, is a point on the horizontal axis, which is 1.802. And we want to calculate the area. So we basically want to calculate. So we have t on the horizontal axis, like I said before. What is the probability of getting a test statistic value of 1.802 or more extreme than that? Or find the area under the T curve to the right of 1.802. Now, there's a difference between a T curve and a Z curve, which I'll tell you in a minute. Let me create some space. So, okay. Each T curve is associated with a degree of freedom. Associated with a degree of freedom. Degree of freedom. DF. Okay. Which is equal to sample size minus 1. Now, in this problem, n is equal to 11. So df is 11 minus 1 is equal to 10. So this is for df 11. Okay. Now we want to find the area to the right of 1.802 under the T curve with the degree of freedom is, degrees of freedom is equal to 10. Okay. 11 minus 1 is 10. Now, like a Z curve, this T curve also extends to, on the right, to a very large number. Somewhere over here is 1E90. So how do I find the area? Okay. So second verse. Okay. So press the second key, then the verse key, which is in the third row, Then scroll down to TCDF. Okay. And hit enter. Okay. My lower value is 1.802. My upper value is a very large number on the right side. So 1, then second button, then comma button gives you the small capital E, then 99. Okay. So lower value is 1.802. Upper value is 1, then second button, then comma button, which is on top of 7. And then that gives you the capital E, and then type 99. What does it mean? It means 1 followed by 99 zeros. Okay. Second, comma, 99. Okay. Now it asks for DF. Remember, DF is degrees of freedom, is 10. So type in 10. And then go down to PEST. So scroll down to PEST, put the cursor on there. Whenever you are on PEST, the cursor is on PEST, hit enter and enter. Enter twice and enter. Okay. Enter and enter. And this p-value, the p-value, so let me clear that. So the area to the right of t test statistic is equal to 1.802, or p-value is equal to 0.0509, you might say. Compare that with alpha is equal to 0.05. So P is slightly greater than alpha. Decision: do not reject 80. Conclusion: at alpha equal to 0.05, there is not enough evidence to support HA. Evidence: because we did not reject 80, we cannot support the alternate to support HA, which states mu greater than 65. Okay, so this is the important part. P is greater than alpha, do not reject 80, and therefore conclude at alpha equal to 0.05. There is not enough evidence to support the alternate HA mu greater than 65. Now that we have done this problem using calculation, let's use the calculator to do this test. So how will I do that? So first I'll create some space here. Okay, the second way of doing it, okay? So change the color of the ink also. Okay. Use TI-84. Okay. So what are the steps? First is press Stat. Okay. Then highlight Test on the top row. Then scroll down to t-test. We are using t-test because we do not know the population. standard deviation. Scroll down to t-test and enter. So first line for t-test, input should be data. This is input. Data, because we have entered the data in L1. So bring the cursor on data and hit enter. Okay, next line is mu0. That is your hypothesized population mean, which is 65. So type mu0 65. Okay. List is L1. Frequency is 1. And we need to move up further. Okay. Frequency is 1. And then comes the, after the frequency, the line is the alternate. I mean, that line is mu is the alternate hypothesis. Remember, we are doing greater than mu0. It's a right tail test. So bring the cursor on greater than mu0 and hit enter. So it should be flashing on greater than mu0. Then go down to calculate, put the cursor on calculate and hit enter. So what did we get? Test statistic T. So T is your test statistic. Is 1.8099. Okay. P value is 0.0502. Very close to what we got before, 0.0509. Okay. Compare that with alpha. Alpha is your level of significance. It's the maximum probability of rejecting H0 when it is true is 0.05. Remember, alpha is maximum probability of rejecting H0 when it is true. When it is true. That is, it is the maximum probability of making type 1 error. Of making type 1 error. Type 1 error. Okay. Now we will move a little bit further. So compare with, so P is slightly greater than alpha. So again, the decision is fail to reject H0. Fail to reject H0. Conclusion at alpha equal to 0.05. There is not enough evidence. To support the alternate hypothesis HA, which is mu greater than 65. Same decision, same conclusion when we did the calculations on our own. Okay. So that's the end of it. I will stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, please share this with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. I'll see you next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.